Hello everyone, Mr. Rossett here, and we are back with another Algebra 1 lesson. Today we're going to finish up our unit on systems of linear equations and finish it by talking about systems of linear inequalities. So let's just jump right in. Down below it says the lines given below are shown in the graph. We have y equals x minus 1 and y equals negative 2x plus 4. And these are going to act as our boundary lines, right? If we think back to two variable inequalities, when we graph them, we have a boundary line that separates the solutions from the non-solutions. They've changed these equations to inequalities, so y is greater than or equal to x minus 1, and y is less than or equal to negative 2x plus 4. And we want to figure out which of these sections of the xy plane, so we can just label them as 1, 2, 3, and 4, right? These two boundary lines create four different sections. We want to figure out which one of those contains the solutions to both systems, to both inequalities. So which one contains the solutions to the system of inequalities? Well, let's break it down. Let's just start with one of the boundary lines. So let's start with this one up here. Y is equal to x minus 1. Well, just based on the y-intercept, we know that that's going to be the red line. So hence why I've used red. Now, to figure out which side of that red line I should shade, well, we should choose a test point, right? Well, let's choose the point 0, 0. So we have y is greater than or equal to x minus 1 at 0, 0. Well, we get 0 is greater than or equal to 0 minus 1. 0 is greater than or equal to negative 1. Well, that works, right? Because 0 is greater than or equal to negative 1. So I would shade this side of the red line, the side that the test point is on. Now let's try it for the blue. The blue being y is equal to negative 2x plus 4. That's the boundary line. And then we want to see which side to shade on for the inequality y is less than or equal to negative 2x plus 4. Again, I could use the test point 0, 0, because that's not on the line. So let's see if that makes this blue inequality true. And I get 0 is less than or equal to 4, which is true. So I am going to shade on this side of the blue boundary line. So if I think about these individually, right, I've shown what the solutions are to each of these by themselves. If I want to show what the solution to the system of this inequality, if I want to show the solutions to the system of these linear inequalities, well, I'm going to look for where the overlap is, right? So where is the shading from both inequalities? Well, that ends up being in this quadrant right here, the one that or this section of the graph, the one I'm shading in green. So what you can do when you're solving these, you can either make it very obvious that, the double shaded part is there, or you can erase the other shaded parts and just leave the double shaded portion. So what I currently have on my page now, these are all the solutions to both of these inequalities. And this is essentially what we're doing today. That is it. You're basically just doing two inequalities, doing the shading for both, setting up the boundary lines, etc., and then just looking for where the shading overlaps. And those are going to be your solutions to the system of the linear inequalities. Let's go do one or two more for practice. And I encourage you to pause the video, try this on your own, work through the steps we just did for the do now, and then come see if you did it correctly. Okay, so for the first one, we'll do this one in red again. I'm going to graph the boundary line y is equal to x minus 2. So y-intercept of negative 2, slope of positive 1. So my boundary line should look something like, oops, it's not very good. Something like that. And yes, it should be dashed because it is just a greater than sign. So we do need to, oops, didn't want to do that. Let's try that again. It's going to erase a little part of the graph, but that's okay. All right, so we have a dashed line there. For our next line, our next boundary line, we have y is equal to negative x plus 1. So y-intercept is positive 1, slope is negative 1. And this one is just a solid line. It looks something like that. Now we need to figure out which side to shade. Now, there's actually a couple, or which section to shade. So there's actually a couple ways you could do this. You could actually just pick a point from each of the 4 sections, right? So you have this section, what's that? There we go. You have this section right here, you have this section here, this section here, this section here. So you could pick a point from each of those sections and see which of those sections fulfills both of the inequalities. But then you may have to test 4 points, right? You may not find the right one until you get to the last section. So you can do it that way, but then you may have to test 4 points. If you do it the way we did above, you're just going to have to test 2. So that's the way I'm going to stick with. I'm going to test the point 0, 0 for both. So if I do it with red, y is greater than x minus 2 at 0, 0. And I get 0 is greater than negative 2, which is true. So I'm going to shade on that side of the red boundary line. Now if I test blue, I get 0 is less than or equal to 1, which is true. So I'm going to shade that side of the blue boundary line. Now it turns out all of our solutions are in this section. I'm going to shade that in green. Then I'll make it more obvious by erasing the other 2. So any point in that green section would work for both of the inequalities. Okay, let's maybe try one more. Actually, we may skip to the word problem. You know what, let's do this one first, the very last one. This one's a bit different. Same process, there's just something we have to do differently when we graph the boundary lines. So let's jump right into that. I'll use red again for my first one. So I have y is equal to 0.25 x minus 4. Negative 4 is our y-intercept. And our slope here is 0.25. So you have a couple of options. You can either rewrite that as a fraction, which would be 1/4. So we could count the change in y, count the change in x, and graph. However, if you didn't recognize that that fraction was 1/4, you may have to find another point a different way. Right? So if you think back to when we first started graphing lines, if I have y is equal to 0.25 x minus 4, I can pick a value for x. So let's say like at x equals, let's just say 4. And I can substitute that in. So I get y is equal to 0.25 times 4 minus 4. That gives me y is equal to 1 minus 4. And that gives me y is equal to negative 3. So my new point would be 4 comma negative 3. I could graph that, right? And that's actually one of the points that's already here, right? That's this point right here. And then you could draw your line between. But you could have chosen a different value for x, like 5, 6, negative 5, negative 4, negative 3, etc. And you would still get a point somewhere on that red line. So it's up to you. If you can recognize what fraction that decimal is, then you can just count the change in y, change in x, or you may have to go ahead and choose a value for x to find your other point. Both ways are acceptable. Solid line, because the sign includes the equals part, let's go ahead and graph the other line. Although we see that we have negative y. So we don't want that. We need to get it y by itself. So I need to divide everything by negative 1. And if I do that, I have to remember to flip the sign. It's not that important for a boundary line, but it will be important when we're testing a point. So my boundary line equation is still y is equal to negative x minus 3. Solid line again. And now we're ready to figure out which side to shade on. Again, I'm going to use 0, 0 for both. It's just a very easy point to substitute in. So let me get rid of some of this. I'll put that back up. Let's test red first. We're going to test it at 0, 0. So I get 0 is less than or equal to negative 4. That is not a true statement. So I'm going to shade on the other side of the red boundary line. I'm going to be shading this side. Now we need to test blue. Remember that our new inequality was, and it's actually, you could just test it the way the inequality currently is written with the negative y. But if you did change it, then you would have to remember to change the sign. So just know that you could test it in either one of these, but if you decided to get the y completely by itself, you would need to flip that sign because you're dividing by a negative number. So again, testing at 0, 0. You get 0 is greater than or equal to negative 3, which is a true statement. So I am going to shade on that side of the blue boundary line. And we can see that our overlap occurs in this bottom right section. We'll get rid of all the other stuff. So the green section, again, the section where all the points in there would work for both inequalities. Okay, let's look at the word problem, and then we will wrap up this video. Originally, I did move on to the word problem, but then when I was editing this, I realized we should have done
one of these other examples because it is completely different from the other ones that we've done. So we're going to go back. We're going to go back and add this in before we get to the word problem. Pause the video, graph these two inequalities on your own, do the shading, and think about what the solution set would look like. Okay, so let's graph the boundary lines first. We have y is equal to negative x plus 2, y-intercept being positive 2, slope negative 1, and our boundary line is solid. Second one, we have y is equal to negative x minus 2. So same slope, different y-intercept, which means these lines are parallel, right? Same slope, different y-intercept. Now we need to think about the shading. Although actually, you know what? Let's make sure we make this a dashed boundary line. There we go. Let's choose the test point 0, 0 for both. I like choosing 0, 0 because it's very easy to test. So let's do the red one first. So I get 0, whoops. I get 0 is greater. What is going on? There we go. Get 0 is greater than or equal to 2, which is false, right? That is not true. So I'm going to shade this side. And for blue, I should have added 0 right away. I get 0 is less than negative 2, which is also false, right? So I'm going to shade the opposite side of the test point here as well. And what you'll notice here is that there's actually no overlap between the red and the blue. And when this happens, quite similar to a system of linear equations, there is no solution, right? There's no overlap, so there's no solutions that are shared between the two. So we would just say no solutions. And again, this is just a special case where none of the shaded regions overlap with one another. So when this happens, again, just no solutions. All right, now we will move on to the word problem.
Okay, so it says Jackson has $360 to buy food for his cross-country banquet. He can buy slices of pizza and individual tacos. He needs to buy at least 200 items. Each slice of pizza costs $1.50 and each taco costs $2. So we need to first write two inequalities that represent the scenario above. X will represent the number of slices of pizza, and Y will represent the number of tacos that he buys. So I'm going to give you a little hint with what the two equations are that you may need to come up with. One is going to deal with the number of items. So total items equals slices of pizza. Let's make that a little better. Slices of pizza plus number of tacos. And our second equation will deal with the price. So total price. And I understand that these are not, sorry, I may have said equations. I know we're writing inequalities. I'm just not going to give you the sign yet. So you're going to think about, okay, what inequality sign should I replace the equal sign with, right? Because we're going to have greater than or equal to, less than or equal to, etc. But the total price, that'll be equal to, or you'll choose an inequality sign, to cost of the pizza plus the cost of the tacos. So pause the video, see if you can come up with what the algebraic form of these equations should look like, and then we'll move forward. All right, so total items need to be at least 200. So at least means the slices of pizza and the number of tacos should be greater than or equal to 200. Slices of pizza is represented by X, number of tacos is represented by Y. So X plus Y needs to be greater than or equal to 200. There's our first inequality. The total price, we know that he has $360, so we can't go over that. So that means the cost of the pizza and the cost of the tacos has to be less than or equal to 360. So the cost of the pizza is going to be 1.50 times X, because it's $1.50 per slice. Cost of the tacos is $2, so 2 times Y. So 1.5x plus 2 times y is equal to 360. Part B says find a solution that works for both inequalities. Show that it works. So they're not saying you have to go through any formal process here. You can just kind of do a guess and check if you want. But try to come up with a number for x and y that works for the green and the red inequality. And I'll give you pause the video and take some time to try to work through that. All right, so one solution would be 100 tacos and 100 slices of pizza. You can see that it works for the green. 100 and 100. That is true, right? 200 is greater than or equal to 200. And if I check it for the red, I'll do a little bit more math here. I end up getting 350 is less than or equal to 360, which is true. So one possible solution, 100 slices of pizza and 100 tacos. And again, you may have come up with a different number because there's not just one answer. You would just need to prove it using both the inequalities. The final thing we're going to do is graph, and this will give us a better idea of what all the solutions may look like, right? So we've just found one right here, but if we can graph it, then we'll see, okay, all of these different points would work. So let's jump down here. Let's remember what our two inequalities were. We had x plus y, x plus y is greater than or equal to 200. And we have 1.5x plus 2y is less than or equal to 360. I just wrote them, I reversed the sides, but the signs still mean the same thing. So x plus y is greater than or equal to 200. I'm going to use this using the intercepts. And I'm not going to go through all the work, but if you substituted in 0 for y to find the x-intercept, 0 for x to find the y-intercept, you would notice that both those intercepts are 200. So this boundary line is going to look like this. Solid, of course, because it's greater than or equal to. For my green, we can do the same thing. We can find the intercepts. And I guess I'll just run through this real quick in case you forget what the intercepts are. To find the x-intercept, you're going to that wasn't good. To find the x-intercept, you're going to substitute in 0 for y, right? And we're just doing the boundary line so we can keep this as an equation. 1.5x is equal to 360. And if I divide 360 by 1.5, That gives us 240. So x-intercept is 240. If I do the same thing for my y-intercept, because substitute in 0 for x, so I get 2y is equal to 360, and I'm going to get y is equal to 180. So there's my boundary line here. And then, of course, I need to figure out which side to shade. Well, I am going to use the test point, 0, 0 for both. Let's do the red inequality first. So at 0, 0. Well, this is not going to work, right? 0 is greater than or equal to 200. That is false, so I'm going to shade the other side of the red. And for the purple, just write this out again over here. We'll also use the test point 0, 0. This is going to work because 0 is less than or equal to 360. So I'm going to shade on this side of the purple. And you'll actually see I should have done a little bit better job of shading the red, because the red actually, right, it's everything on this side. So it does dip right into here. So the overlap is actually this sliver of space here, right between the red and the purple. So I'm going to erase the other sides. And our solution set would be what I shaded in green. It doesn't look like a ton of numbers, but you also have to realize that the graph, right, is being counted off by 20s. So there are more points in there than you think. One thing to be aware of, right, is that even though we shaded that entire region, not every single point in that region works, and that's because this is a word problem, right? Think about why some of the points inside of the green region may not work in terms of this word problem, right? If we just looked at these inequalities, it works, but when we think about the context of the word problem, pizza and tacos, it may not make sense to say that every single point in that region works. So pause the video, take 30 to 60 seconds to think about why. Why may we say not every point in there would work? Well, and that's because some of those points in there are going to be fractions and decimals, right? So, one of those points may be, let me just give you an example, right? There's a point in here like 220, comma 0.5, right? Well, that would mean we're buying 220 slices of pizza and half a taco. But we're not going to buy half a taco, right? We're only going to order whole number tacos. So, 1, 2, 3, 4, etc. So any point with a decimal or fraction wouldn't be included in our solution set. And you'll also notice that I only include the first quadrant, right? I didn't include any negative numbers because it also wouldn't make sense to buy negative numbers for tacos or pizza. So again, always good to think about the context of a problem when you're dealing with a word problem and not just the inequalities on their own. Okay, that's going to wrap it up for this video. I believe you do have enough to finish the rest of the problems here. Until next time, though, enjoy the rest of your day, and we will hopefully see you for our next video.